Hi, in this video, we are going to take a practical illustration of how balancing an equation works, okay? So again, for this case, I will just use a simple equation just so it's easy to digest. So for example, you might have hydrogen gas reacting with oxygen gas, forming water. And again, I specifically pick this equation so that it's simple to digest. So what that means is if you look at this in an illustration, you are looking at hydrogen gas. So let me represent hydrogen atom as this red. So hydrogen gas H2, so two red atoms. And then oxygen gas is two blue atoms because obviously oxygen gas, just like hydrogen gas, is also diatomic. So two atoms. And then they react and form water. Now, water is H2O. That means two hydrogens for one oxygen. So remember, our oxygen is the blue one. So it means that you have one oxygen, right? And then connected, and that is bonded with two hydrogens. So two hydrogens here. And again, now, if you look at just the illustration, even not the equation, you know that something is wrong. And something is wrong because here you have two atoms of hydrogen, right? And then after the reaction, you have two atoms of hydrogen. But for the oxygen side, you have two atoms of oxygen. And then after the reaction, you seem to only have one oxygen atom, right? So if we think about the definition of a chemical equation, which is a rearrangement of the atoms, then we could say, well, let's track where the atoms are. Well, this atom probably is the one that became this atom. And then this atom here is probably the one that became that atom. This atom, oxygen, became that atom. Now you have a problem. Where is the second oxygen? The second oxygen atom is missing, right? So in reality, this is what we mean when we say the equation is unbalanced, meaning one or more atoms, the number of atoms are missing or some popped out in existence. And that's not good because, again, in science, you cannot just create or destroy anything, or in this case, atoms, out of with for no reason, right? So here, it means that something is missing. So if I'm really going to be realistic, right? If I'm going to depict this one in a realistic sense, then I would say, well, maybe you have the hydrogen, right? Atoms reacting with the oxygen atoms. And let me change this to blue because we used blue before, oxygen atoms. And then what happens is they react. And the two hydrogens here bonded with one oxygen atom. And obviously there's a second oxygen. So there should be, right? There should be a second oxygen here, right? So now this is hydrogen 2 plus oxygen 2. I mean, hydrogen gas plus oxygen gas reacting to form water plus what we call elemental oxygen, meaning oxygen that exists as an element. It is not bonded to anything because remember, you've exhausted all your options. These two are being used up in this molecule. This one oxygen here is bonding inside the molecule. So this one molecule, one atom rather, is alone. It's isolated. But the problem is this form of elemental oxygen, this does not exist, or it's very rare to exist in nature, and this is very unstable. So when we say unstable, it means that it really can't exist as it is. It will always react with other things in the environment. Obviously, we have an isolated case here, so we can argue that, well, if there's nothing to react to, it will become like that. But in the real world, when you mix hydrogen and oxygen gas, for example, and let them react, they are inside containers, and these containers are exposed to the environment and exposed to other things. So this really never happens, right? So now what you can say is, okay, how do I fix this? And then if you think about it hard enough, it's really easy to fix. You would just say, okay, this oxygen here, one of the oxygen, is able to pair up with two of the hydrogens, right? So therefore, if I'm going to make another like this, I need two more hydrogens, right? Again, the problem is here, if you use one of these and one of this, you end up with one of this and then half, kind of like a, not a whole another, like not a whole other molecule, but just oxygen in elemental form without the hydrogens. So now you say, so the problem is really you need two more hydrogens, right? So if you need two more hydrogens, it fixes things. You have two molecules of water, right? And this water exists in nature. The problem is it's not balanced because, again, you have four molecules here of hydrogen, but you only have two molecules here. I'm sorry, you have two atoms of hydrogen, and you only have two atoms of hydrogen here. Two atoms of hydrogen and four atoms of hydrogen on the right side. So, what to do? Well, add more. And the moment you realize this, the moment you do that, you realize that this is the correct way. Because think about it, it means that these two hydrogen here, two hydrogen atoms, and the first of the oxygen atom will form this. And then this second pair of hydrogen atoms with the oxygen will form that one. So this is the more logical way of doing that, right? So now you can see that it's not H2, but 2 units of H2 plus just 1 unit of oxygen. They form water, but not just 1 unit of water, but 2 units of water, right? So that is really what it means when we balance an equation. We are at the fundamental level, we are accounting for the number of atoms, right? At times when we balance equations, it could feel like it's procedural, like we're changing the coefficient out of some arbitrary rule that someone just invented. But in reality, that's what we're doing is this: we are accounting for the missing atoms, and looking at a practical solution to make everything work. And again, the practical solution here at first was you have kind of like a, a, an oxygen atom which is alone. It has no hydrogen atoms because you have exhausted all the two hydrogen atoms in forming the first molecule. Then you say, okay, then what is lacking is to add two more hydrogen atoms, right? And that means you have to add one molecule of hydrogen gas, because one molecule of hydrogen gas is composed of two hydrogen atoms, right? And then you do this. Okay, so now you have hydrogen gas plus oxygen gas plus reacts and form water, or to be specific, two molecules of hydrogen gas plus one molecule of oxygen gas forms two molecules of water. Obviously, you could have cheated and said, wait a minute, sir. If I have this, which is H2 plus O2, and then forming water, and it doesn't work out because, again, something is missing. Like, for example, here, you have hydrogen gas. That's how we represent it. oxygen gas. This is how we represent it. Then water is just this oxygen with 2 hydrogen. And then we say, well, something is missing. We have the missing second oxygen. So why don't I just do this, sir? Why don't I just do this? That hydrogen gas plus oxygen gas, and then it results into, why don't I just do this so that it's all accounted for, right? Because if I do this, you have 2 hydrogen atoms when you started, 2 oxygen atoms also when you started, and then you have 2 oxygen atoms after the reaction and 2 hydrogen atoms after the reaction. Everything is accounted for. Well, yes, technically speaking, if you are just looking at accounting where the atoms have gone, that is correct, right? So you have hydrogen gas plus oxygen gas, and then they create this. But remember, this is not H2O because H2O is just 2 H's and 1 O. But this is 2 O's and 2 H's. So this is H2O2. And this is now hydrogen peroxide, and it's not water anymore. So the issue with doing this is not that it doesn't account for the number of atoms, it does, but you have now changed the product. So instead of hydrogen gas and oxygen gas forming water, you now have hydrogen gas and oxygen gas forming hydrogen peroxide, and it's now a different product from what you intended. So altogether, it's a different chemical reaction. So you're not describing the same chemical reaction. So what's the takeaway? The takeaway is that's why here, if you notice, it's still H2, it's still O2, it's still H2O, still H2, it's still O2, it's still H2O. We have managed to balance it. How? By never changing the subscripts. We only change the coefficient. So here, the coefficient was 1 molecule of H2. Now it becomes 2 molecules of H2. Here, the coefficient is 1 molecule of water. Now we have changed it to 2 molecules of water. And that's fine because 1 molecule of water is just water, just like 2 molecules of water. So we are not changing the product. Here, it solves the accounting problem. H2 plus O2 is it equals H2O2 or hydrogen peroxide. But this is now a completely different chemical reaction. And remember, the point of a chemical reaction or chemical equation is to represent a specific chemical reaction. So if what you had in mind was hydrogen and oxygen reacting to form water, and what you ended up with is hydrogen and oxygen reacting to form hydrogen peroxide. So altogether, you are not expressing the same chemical reaction, and therefore, the whole point of representing what chemical reaction you had in mind is defeated, right? So I guess the whole point of this video is really to visualize like why can't we just change the coefficients, because if you change the coefficients it's much easier to balance, right? So H2O2, you have two H's and one O. So how do we balance? We change the subscripts. I'm sorry, not coefficients. I'm not talking about coefficients here. I'm talking about subscripts. So instead of H2O, let me just make it H2O2. Again, it solves the accounting problem, but it changes the whole chemical reaction completely, and you don't want that. So as a rule of thumb, when we balance a chemical equation, we really change just the coefficient and not the subscripts, because we don't want to change the identity of the reactants nor the identity of the products. But we can change the coefficients, because remember, the coefficient doesn't change what it is, it just changes the amount. So 1H2 is just hydrogen gas, but only 1 molecule. 2H2 is still hydrogen gas, but now you have 2 hydrogen molecules. I mean 2 hydrogen gas molecules. The same thing with water. One H2O is water. Two H2O is still water, but one H2O is one molecule of water. Two H2O is two molecules of water. So you're not changing anything. And I guess a second point of this video is for you to kind of see like a visualization of what it means to balance. So for example, here this is the unbalanced equation. Again, if you just look, if you just focus on the figures, you would see that one blue ball is missing, one oxygen atom is missing. Here, they're all accounted for, but what you did by increasing the number of coefficients is uh, increasing the number of atoms that you started with. And again, with that, you can see that you started with 4 red balls or hydrogen atoms, and you ended up with 4 hydrogen atoms. Here you have 2 oxygen atoms. You ended up with 2 oxygen atoms. The only difference is, again, they rearranged into new configurations, which is the whole point of a chemical equation. Okay?